All right, guys, we're back here for 7-7, and as we do in a lot of the chapters that we do, is we talk about these transformation rules. How do we take the parent functions of exponential functions, logarithmic functions, and how do we get them to move up, down, left, right, stretch, compress, do all those types of things? So again, some things that we're familiar with, and again, you have little notes here. Refer back to these. Don't be afraid to throw down some examples. But what we're going to notice for exponential functions is that if it's going to be horizontal, we're going to see those transformations taking place in the exponent is what we're going to see. Notice how if we're getting it to go right or left, it's up in the exponent with the x. And if we're going to get it to stretch, it's going to be up in the exponent with the x as well. All those same things kind of apply. Now, once again, for reflections, remember that we have, if it's a negative out front, it's going to reflect across the x. If the negative is in the exponent, it's going to reflect across the y. Now, again, you always have the ability in Desmos to graph the original function and the transformed one, and then you can a lot of times see what happens. So let's try a few of these. All right, so how is the graph transformed? If we did 2 to the x, what would 2 to the negative x plus 1 do? All right, so we're looking at, okay, what would a negative up there do? That would reflect it across the y-axis. And then what would the plus 1 do? Well, that would move it up 1. So we got to be able to talk about, don't worry about the s, but just talk about the transformations is what we're looking for. All right, how about if we had e to the negative x? So e to the x is the parent function. So once again, the negative up there is going to be reflection across the y-axis. Now this time the plus 1 is up in the exponent. So what that's going to do is that's actually going to move it left 1. And again, don't be afraid to refer back to those rules as we do these. All right, now what happens if the parent function here is 2 to the x? So what happens when we multiply in front by 2? Well, remember, that's a vertical stretch of 2. And then once again with that negative, and once again, that's going to be the reflection across the y-axis is what that's going to do. And again, don't be afraid to graph those and see what they look like if you're really not sure, but remember those rules. Now, again, we can do the same thing for logs, same rules, and remember, whether it's a log or a natural log, it doesn't matter. Once again, if it's going to be horizontal, again, we're going to see it in parentheses is to be horizontal. We're going to be in the parentheses with the x if it's horizontal. All right. And once again, we're going to see here that a negative out front is a reflection across the x, where if the negative is in parentheses, it's across the y. Now, whether that's a log or a natural log, it doesn't matter, okay? Because we know that the natural log is just log base e. So, all right, so let's talk about the transformations. Once again, putting a 5 out in front, that's going to be a vertical stretch of 5. And if we go minus 2, that's going to move it down 2. Notice no parenthesis there, so we know it's vertical. All right, what if we have something like this? So our parent function here is the natural log. Well, the negative x, that's again going to be a reflection across the y-axis. And the plus 2 is in parentheses, so what that's going to do is that's going to move it left 2. Okay, don't be afraid to look back at those rules, get comfortable with them. It's a nice thing to do. All right, so now let's actually, they're going to give us the transformations, and now what we want to do is we want to transform the 4 to the x. So we want to reflect across both axes. So we're going to want to put a negative in front and a negative up top. And then if we want to move it down 2, we have to go minus 2. All right, kind of cool, crazy, kooky. I like it. All right, so now we have the natural log of x. It's going to be compressed horizontally by a factor of 1/2. So that means we're going to have the natural log. If we're going to compress it horizontally by a factor of half, that means we're going to go 2x inside the parentheses. And then if we're going to move it 3 units to the left, we have to go plus 3 is what we're going to do. Wow. Okay, those are some good ones there. All right, so lots of different ones that we can work on. Let's try one more. All right, so we're going to start with the log of x. So we're going to go to the left. All right, so let's go log 3 units to the left. We know that that is going to go x. Let's see, that would be a plus 3 in the parentheses 1. And if we want to stretch it vertically by a factor of 2, we're just going to multiply out in front by 2. All right, so again, get used to those rules. Use those notes, guys. Get comfortable with that and get some practice with that. And we'll do those transformations. Until next time, I'm Mr.